A parallel plate capacitor has circular plates of 8.2 centimeter radius and 1.3 millimeter separation. In part A, we're going to calculate the capacitance. And what we have essentially in this question is a parallel plate capacitor. They even tell us it's a parallel plate capacitor. And to calculate the capacitance of such a device, we have to use the following equation. We have a fundamental constant multiplied by the area of one of the plates and then divided by the plate separation. So really all we need to do is understand the area, and then we'll be able to successfully solve for this. They do mention that the plates are circular, so we just have to use the expression for the area of a circle. And of course, the area of a circular plate would be pi times the radius squared. Indeed. So now what we're going to do is plug in the known values. We do have to be a little bit careful and use standard values. So for example, they told us the radius is 8.2 centimeters. But we need to convert that into meters. So we can just multiply the 8.2 by 10 to the minus 2. That gets it into meters. The plate separation D is given in millimeters. So we have to multiply that value by 10 to the minus 3 to get it into meters. And then we have the fundamental constant, which we will also plug in. So let's go ahead and do that. And when we carefully plug that into our calculator, we can see that the capacitance is approximately 1.44 times 10 to the power of minus 10. And then dimensionally, we are calculating capacitance. So what happens is the meters squared here, along with the other meters present in the setup, cancel out. And that's going to leave us with the fundamental unit of capacitance, which is the farad. So this is the correct answer. If your homework system wants this in picofarads, then we can say 1 picofarad is equivalent to 10 to the minus 12 farads, and that setup would eliminate the farads, leaving us with our answer in picofarads, which would turn out to be approximately 144 picofarads. So that would be an equivalently correct answer to part A. In part B, we are asked to find the charge if the potential difference between the plates is 120 volts. So this is also a fairly straightforward idea because the charge stored on each plate, or the magnitude of charge stored on each plate, is going to equal the capacitance times the potential difference. So all we need to do is take the capacitance that we calculated earlier and then plug in also for the V, the potential difference, the given value, which again was 120 volts. So let's go ahead and do that. And when we calculate that, we can see that the magnitude of charge stored on each plate is approximately 1.73 times 10 to the minus 8. That's a standard unit of coulombs. If we need nanocoulombs, which your homework system might request, you could say 1 nanocoulomb is 10 to the negative 9 coulombs. You multiply by that conversion factor in order to cancel out the coulombs, and you would be left with about 17.3 nanocoulombs. So that would be an equivalently correct answer.